Hi everyone, my name is Tran. I'm from the University of Notre Dame, and today I'll be talking about Parsl plus TaskVine, bridging the data gap for high-performance scientific workflows in Python. I'd like to note beforehand that our Parsl TaskVine integration work results in the new TaskVine executor, which is merged to the Parsl repository and ready to be used today. So just want to throw that out, and I'm not sure why I can't see. Okay, let's start with something that's familiar to us all. We all know that Parsl allows users to invoke arbitrary functions remotely. So, for example, I have a function foo here with some arguments. Then the way Parsl invokes this function remotely is it's going to roughly serialize the function object and the arguments to two files. Then either stream or stage them over to a compute node, load the Python objects up into a process, and then run the function. That's it, right? Right. No. The key word here is that a function is arbitrary. So by that, I mean a function can import arbitrary package dependencies, XYZ here. It can open input files to read from, open output files to write to, and this diagram on the left, it really looks like an iceberg, where the tip of the iceberg is the function object and the arguments. But under the hood, a function will need its package dependencies, input and output files, and then maybe temporary files which are not really input files and they are not really output files. And Parsl automatically manages the function object and the arguments for you. But it usually relies on a shared file system on an HPC facility to deliver the dependencies and the files to the worker node. And this is going to create a big problem for the shared file system, because when you run a large-scale workflow consisting of thousands of functions, then all functions start at the same time, which will overload the metadata server, because they will ask for the same set of package dependencies and maybe for the same subset of input files. And the problem here is that a shared file system is reactive only because it isn't informed by the workflow execution. So it only gradually reacts to the spiking system load at startup time. There are some catches involved in this process, but they aren't really effective because a workflow execution is a one-time setup. And this happens over the course of a workflow, so it will reduce the performance of a workflow execution and introduce large deviations in the TaskVine execution time, in a task execution time, something like that. To remedy the problem, we have the following insights. Number one, it's costly to move data in and out of a cluster. Number two,
recording in progress.
Number two, there's unused local disk storage on compute nodes. And number three is that data on the local storage of compute nodes aren't used at all throughout the workflow execution. So our solution is to integrate Parsl with TaskVine, which is a workflow execution engine developed and maintained at the University of Notre Dame. And it manages data proactively. And by that, I mean all the data stays in the cluster until it's not needed. And there's no remote I/O to the shared file system at all, because all data are staged to the local storage of a compute node, or there's only local I/O over the course of a workflow execution. And of course, we will eliminate the problem of shared file system overloading. I have an example here for the full function. So the first thing is that it's going to be given to the Parsl data flow kernel for analysis, and then it's given to the TaskVine executor manager process. And then the first thing it's going to do is going to send the arguments to a TaskVine worker, which takes over an entire compute node. And then the manager process will instruct other TaskVine workers to send over the dependencies, the function object file, and all input files to that worker, so it can start executing the full function. And this is, of course, without using the shared file system flow. we evaluate the TaskVine data distribution method by running a hyperparameter search workflow on a neural network model. The configuration of the workflow is on the left, but we can come back to that later. On the right, we show the execution time of the same workflow using the shared file system, using TaskVine, and if we allow TaskVine to catch some information beforehand. The y-axis shows the execution time in seconds, and the x-axis shows the number of workers. So we start from 32 and go up to 256. But 32 workers, we can see that the shared file system can sort of keep up with the TaskVine data distribution method. But as we increase the number of workers, we increase the degree of concurrency of the workflow, and thus we increase the I/O pressure on the shared file system. And by the time we get to 256 workers, the execution time of the workflow is cut down by 36 seconds. Okay, it's cut down by 30%. Using the TaskVine compared to the shared file system. So the TaskVine is much more scalable in this approach. Because I have 1 minute. We also have a serverless optimization. Before we run a fresh Python interpreter process for every function call. Now we, instead of running a fresh Python interpreter process, we run one Python interpreter process and then fork itself for every function call. And the benefit is, I'm just going to skip to the next slide. With the regular way, I tested using running 20,000 simple functions. The regular way takes 700 seconds. The serverless way takes, when I only have one function slot per worker, it takes only 35 seconds. So we already have like 20x speed up. And as I increase the number of function slots, you can think of it as a level of concurrency. It goes down to 50 seconds. So we achieve like a 50x speed up, which is great for short running functions that run from several seconds to a minute. Yeah, so you can try it now. So first we would install the TaskVine with Parsl via Conda, if it's the recommended way. And then you only have to change the configuration of your executor. It's only like a 6-line change. We have more examples in the URL there. And finally, I'd like to note that TaskVine is a real software product from the Cooperative Computing Lab at the University of Notre Dame. We've been working with the Parsl team for a year or two by now, and we're eager to collaborate with new users on applications and challenges. Thank you.
We have a question from the room for Tran. Do you have measurements for like different patterns of data movement between the workers? Like if you try to do broadcast of a single file versus files being moved in specific patterns, do you see any common difference?
So files only move when there's a function that needs to be executed.
Okay, so it's going to be
yeah, it's going to be. Thank you.